Good afternoon, girls. We'll continue with the chapter quadratic equations, and today I will teach you how to find the roots of the quadratic equation by the formula method. Okay, so you all know that the quadratic equation is, the general form is ax square plus bx plus c equals to 0, right? This is the general equation. Now first we will find whether the given equation has real roots or not, and for that we will find the value of the discriminant. Okay, what is discriminant? To find the discriminant we will use the formula b square minus 4ac. Now what is b square? B will be this value, a will be this value, and c will be the given value, and it will be different for different equations. Now, if you get the value of discriminant as greater than or equal to 0, then the given equation has real roots or real equal roots. That depends on the equation given. So I will check that also. So what I told you is, first we will write, the equation will be given to us. We will then find the value of the discriminant, which is equal to b square minus 4ac. And if b square minus 4ac is greater than or equal to 0, then only we will apply the formula to find out the roots of the equation. But if the value of the discriminant is less than 0, then it does not have the real roots. Okay, now the formula for calculating the roots of the equation is minus b plus b square minus 4ac upon 2a. This is for one root. There will be two roots of the quadratic equation, I told you before also. And for the second root you will write minus b square minus 4ac upon 2a. That means in the first one it will be minus b plus root of b square minus 4ac upon 2a, and in the second one it will be minus b square minus 4ac upon 2a. Now since the formula is same, we can just combine and write the formula as minus b plus minus root of b square minus 4ac upon what? 2a. So we can write the quadratic equation formula for finding the roots is equal to minus b plus minus b square minus 4ac upon 2a. So you will get two roots. In the first case you will add, and in the second case you will subtract. And when you will get the two roots, that roots will be the answer of the given quadratic equation. So first we will find the value of the discriminant. The discriminant capital D is given by b square minus 4ac. The value of b, a and c you will get from the equation. If it is greater than or equal to 0, then it will have real roots. And if it is less than 0, it will have no real roots. You will not apply the formula. And the quadratic formula is, for finding the real roots, is equal to minus b plus minus b square minus 4ac upon 2a. So remember 3 points. If you will write these 3 points in your notebook. So if d is greater than 0, d is equal to 0, and d is less than 0. Now what is d? D is equal to discriminant, and the value of discriminant is b square minus 4ac. So when d is greater than 0, the equation will have two real roots, right? And these two real roots will be distinct. Distinct means they will be different. When we have d is equal to 0, then the roots will be two equal real roots. Okay? And if the value of d is less than 0, you will write no real roots. So depending on these three conditions, you will first find the value of d and then check out whether it is greater, equal to, or less than. If it is greater than 0, you will come to know that the roots are real, but they are distinct, means different. If the value of d is equal to 0, then the roots will be real and they will be equal. And if the value of d is less than 0, then it will have no real roots. So these conditions can be applied in the exercise questions, and the quadratic formula is minus b plus minus root of b square minus 4ac upon 2a. So we'll take up the exercise question number 4.3. 4.3. Actually, see, the question is find the roots of the quadratic equations by the completing the square method. Just now I have not taught you what is the completing the square method. I am teaching you quadratic formula method. So you will complete this question by the quadratic formula method. Okay, and what is the question given? First one, 2x square minus 7x plus 3 is equal to 0. Yes. Now we will check out what is A. A is 2, B is minus 7, C is equal to 3. Now what we'll do, we'll first write the discriminant b square minus 4ac. What is b square? Minus 7 square minus 4 into, what is a? 2, c is 3. 7 sevens are minus 7 into minus 7 is 49. 4 2s are 8, 8 3s are 24. So here you get 5, that is 25. Obviously 25 is greater than 0. So you will get what type of roots? Two real distinct roots, right? So remember the value of 25, because b square minus 4ac will be used in the question, in the formula I mean. So let's check. A is equal to 2, b is equal to minus 7 and c is equal to 3. Now we write minus b plus minus b square minus 4ac upon 2a. Now since you have already calculated b square minus 4ac, you don't need to find it again over here. So we will write the first root. We'll write roots. The first root will be minus, what is b? Minus 7 plus minus, okay, what is b square minus 4ac? 25 upon 2 into a is how much? 2. So see that you correctly apply the values. Here you get 49 plus, I'll take up the first root and I'll take the plus sign. For the root of 25, I will write 5 upon 4. Now 49 plus 5, 49, 50, 54. 54 upon 4. Yes, 9, 10, 14, 54. So 2 2s are 4, 2 27s are. So one root is 27 by 2. Right? Now another root will be minus and sorry, I made a mistake here. I'm sorry. It will be, we are not finding the square here. 7 plus 5 upon 4. Minus and minus plus. By mistake I took the root square of 7, which was wrong. 7 plus 5 will give you what? 12 upon 4, and that is 3. So this is 3, and the other value will be 7 minus 5 upon 4, and 7 minus 5 will give you 4. 4 by 4 will be equal to 1. Okay, so I hope you've understood. These are the two answers. One is 3, one is 1. So these are two real roots and they are distinct roots. Okay, so this is how we apply the quadratic formula in the given quadratic equation. So we'll check once again. We will first find the what? Discriminant. We will check whether the discriminant is greater than or equal to 0. If it is greater than 0, it has two distinct real roots. If it is equal to 0, then it has two equal roots and they are real. And for the b square minus 4ac, which is less than 0, it will have no real roots. Then we'll use, first find the discriminant, then we'll apply the formula. Formula is minus b plus minus square root of b square minus 4ac upon 2a, and then we'll continue. Here we get a, b and c from the given equation. A is 2, b is minus 7, c is 3. Remember that the signs are important. Here minus into minus plus, 7 plus minus root of 25 will give you 5. 7 plus 5 is 12 by 4, it will be 3, and 7 minus 5 will give you 4 by 4, which is equal to 1. So these are the two real roots and they are distinct. Okay, so you will be able to, I think, apply the values and use this formula. Now in the exercise 4.3, you can complete question number 1 and take up some questions from the previous exercise also. This is for your practice, because whichever questions we have done by factorization can also be done by the quadratic formula method. Okay, so you can practice those, and if you have any doubt you can ask me. Okay, so I hope you've understood here. 7 plus 5 by 4 and 7 minus 5 by 4. Plus and minus means for the first root you take plus sign, for the second root you take minus sign. So solve these few questions and also from the exercise, previous exercise which we have done by factorization method. Okay, and if you have any doubt you can ask me. Okay, thank you.